The process begins when a ligand, in this case epinephrine, which is represented by this piece of green paper, interacts with the receptor on an integral G protein. This triggers the GDP, which is attached to the peripheral protein on the integral G protein, to be replaced by GTP, which activates it and causes activation subsequently of the adenylyl cyclase protein. When the adenylyl cyclase protein is activated, many ATP interact with it, producing CAMP and
You don't have to put it doesn't, if it's over a minute, it won't.
CAMP and 2-phosphates, because the ATP is stripped of 2 of its phosphates, leaving over adenosine monophosphate. The adenosine monophosphate, CAMP, then interacts with a protein kinase, removing the protein kinase inhibitor from it. This leaves the kinase active, so that it can interact with an ATP. When this interaction takes place, an ADP is left over, and the remaining energized phosphate from the ATP is attached to the protein kinase. The protein kinase then interacts with a phosphorylase and phosphorylizes it, which makes it active. Once it's active, it is able to perform its function, which is to split glycogen into glucose. Thus, the process triggered by the epinephrine ligand causes an increase in the amount of glucose in the cell.